Hello, my name is George C. Bradley, and today's lesson is on how to run a two-way analysis of variance using SPSS. With a two-way analysis of variance, each participant must have scores on three variables, two factors or two independent variables, and a dependent variable. Each factor divides cases into two or more levels, while the dependent variable should be at the interval or ratio level. Let's take a look at our data set. The title of this data set is student-athlete.sav, and we have two factors. Two independent variables. The first, gender, and male equals 0 and female equals 1. Athlete, non-athlete equals 0 and athlete equals 1. And our dependent variable, miles, minute, duration. And the dependent variable stands for the time in minutes to run a mile. And this database is online and it's free. Let's take a look at our data set in SPSS. Right here, as I said, one of the factors, gender, the other, athlete, and the dependent variable is how long it would take to run a mile in minutes. Let's go to Analyze, General Linear Model, Unit Variance. Our dependent variable, as we stated before, mile minute duration. Our fixed factors, we have two. We have one, gender, and our other is athlete. And we're going to leave our model here the same, a type 3 model. I'm going to keep contrast the same. We'll go to our plot here, and we're going to look at gender, add. We're going to look at athlete to the horizontal axis, and we'll add. And then we will have athlete to our horizontal and gender to our separate line, and we'll add, and we'll click on continue. We don't need a post hoc because there are only two groups in each one of our factors, so we will continue there. We don't have to save anything, so we'll move forward there. We'll look at options, and with our options here, we want to display the mean. We want to display the overall mean. Display gender, athlete, and then we also want to display the interaction here. Compare main effect, and we'll keep it there. Display descriptive statistics, effect size, power, and homogeneity tests right here. Okay, and let's go to OK here. Now let's take a look at our data. Our first chart here, we have between subject factors, we have the gender of that athlete, and we have the number. You can see with males 181, females 202, non-athlete 221, and athletes is 162. And as you can see right here with the means, now when you run the mile, the smaller number is good. The larger number is a little slower. So you can see something that sticks out here. The male athlete is the lowest, and that's strong. And you can say the female athlete is right behind, and you can see right here with the female non-athlete, that's pretty high. And if you can look at these cells here, you can see these cells are not even, and normally that can cause a problem. And as you can see right here, the standard deviations have a pretty large spread. And so when we go to Levine's test here, Levine's test, the test of homogeneity, the test of variance, you can see that it's below 0.05. And when it's below 0.05, that means we will reject. And when we reject, that means that these variances are not equal. These various variances are not equal. And that violates a major assumption that we have there. And when it violates that assumption, we have to declare that in our limitations. But be mindful of a two-way analysis of variance. It's very robust, and a lot of time that's kind of common when you have cells that are not equal, and when you are conducting a two-way analysis of variance, you'll see that at times, so you have to declare it. Okay, let's look at our test between subject effects, and we'll go down here and we'll go to gender, and gender is significant. So there is a significant difference between male and female in the time that they run a mile, and between athletes and non-athletes, which we would expect that, and the interaction. Now let's look at eta square here. You can see here that 17.2% of the variance will attribute to the time in running, the time for running the mile. And as you can see here with athletes, that's almost, believe it or not, that's twice as much, 35.8% of the variance will attribute to the dependent variable. And as you can see here with the interaction, 12% of the variance will attribute to the dependent variable. You see we have our grand means, we have our pairwise comparison, which we've already seen in the main chart. And as we move forward, we have this information. We will go to the plots. In our first plot, as you can see, the male time is much better than the female time. And as you can see, the time is a lot better than the non-athlete. And look at your interaction here. You have in blue male, not a large difference there between the athlete and the non-athlete, but look, with the female, you have great interaction going on here. So there is significant interaction here. Are there any questions? If you have any questions pertaining to a two-way analysis of variance, please email me, GeorgeCBradley59 @gmail.com. Thank you.